So part 2 of section 1.2 is where we're going to look at domains of some more complicated functions. And then we're also going to deal with something called the difference quotient. So let's look at this function here. We have f of x equals the square root of 25 minus x squared. Well, we know that we can't have a negative inside the square root, so we're going to have to set the stuff inside the square root to be greater than or equal to 0. So 25 minus x squared is greater than or equal to 0. Well, there's a couple ways we could solve this. When we did quadratic inequalities, we factored and we made a sketch and we were able to find our interval that way. Now, one of the things to note is that our a value was always 1, was always positive, so our quadratics opened upwards, whereas this one, our a value is -1 because of that negative in front of the x squared. So if I rearrange this, okay, we could say negative x squared plus 25 is greater than or equal to 0. And we can still factor that by first factoring out a -1, and that would work too. So I'm going to show it that way, and I'm also going to look at ways where we can use an interval test. So we factor out a -1, and we're left with x squared minus 25 is greater than or equal to 0. Well, again, we know that we can factor that to this part, x minus 5 times x plus 5. So then we have -1 times x minus 5 times x plus 5, which is greater than or equal to 0. So when we draw our sketch, okay, we have 5 and we have -5. However, this quadratic now opens downwards because of that -1 in front. So our graph will look like this instead. And we want the values that are greater than or equal to 0. So we want above the x-axis. So what that does is that allows us to say that our solution set is -5, 5. And we know that we have brackets because it's greater than or equal to. So using an interval test, you would follow the same process. We would still get our two zeros, -5 and +5. And what you would do is you set up a number line and say, okay, here's -5, here's 5. And you would test points in each of these three intervals. You would test points that are less than -5. You would test a point that's between -5 and +5. And then you would have to test a point that is greater than 5. So you're testing 3 points. And one of them you should always test is 0. And if we plug in 0 to our original inequality, 25 minus 0 squared, is that greater than 0? Yes, it is. So yes. If we plug in something smaller than -5, let's say we plug in -6. Now we might get tripped up with the negatives here. So I want to show you what I'm doing. So if I plug in -6 for x, 25 minus -6 squared. Okay, I get -11. So that can't happen. Now I plug in a value larger than 5. Let's just plug in +6. I think you know where this is going. Okay, we get -11 again. So these two intervals do not work. So the only interval would be from -5 to +5, which is what we got when we did the quadratic sketch. So either way is okay. I think the quadratic sketch is probably a little bit quicker right now. So let's look at example 2. 7 over x squared plus 4. Remember, we are only concerned, when does the denominator equal 0? Well, x squared plus 4 equals 0. That's never going to be true because when we subtract 4 from each side, we get x squared is equal to negative 4. Can't happen. So negative infinity comma infinity would be our domain. Example 3. Okay. In example 3, we have an odd root in the denominator, so anything goes in an odd root, so we don't have to worry about that. But the denominator here, we have to check and see, can this equal 0? You set it equal to 0. We can factor out a GCF of 5x, and we're left with 2x minus 1 equals 0. Well, the 5x right here, that tells us that x is equal to 0. And then 2x minus 1, we have to set that equal to 0 and solve. So 2x equals 1. Divide by 2, we get x equals 1/2. All right, so we have two values that the domain can't equal. It can't equal 0, and it can't equal positive 1/2. So we can say x can't equal 0, and x can't equal positive 1/2. Now, example 4. Okay, we got some issues here because we have an even root, so a square root in the numerator, and we have a denominator that has a variable in it. So we have to do kind of two things to this problem. First, we take the inside here, and we say, okay, that inside, x squared plus 5, has to be greater than or equal to 0. And then we will go ahead and solve that. So we continue this. We have x squared minus 5 from both sides is greater than or equal to negative 5. Well, we can look at that and say, well, x squared is greater than or equal to negative 5. When we square root both sides, that's going to give us an imaginary number, and we're not there yet. So even though we have an even root in the numerator, when we set up our inequality, we see that there are no domain restrictions for that because this has no, the solution for this is all real numbers. No matter what number I plug in for x right here, when I square it and add 5, it's always going to be bigger than 0. So luckily for us, the numerator has no restrictions. Then the denominator, the only value we can't have in the denominator is 0. And when we add 4 to both sides, we get x equals 4. So our domain for this one is x cannot equal 4. Right, now on the next page, we can also use our graphing calculator to identify domain and range as well. When using the trace feature, there will be no y value when the function is undefined. So if we look at this and you type in y equals and the square root of 16 minus x squared, and we graph that, look, it looks like a semicircle, and we see that when x is 0, y is 4, and if we go further away, after 4, look at our y values go away. So that means that the biggest x value we could have is 4, and the smallest x value will be negative 4. So our domain is negative 4 comma positive 4. Now you might notice a pattern here. The square root of 16 is 4. Oh, negative 4, positive 4. At the very beginning up here, we had 25 minus x squared. Well, what's the square root of 25? 5. So our domain was negative 5 comma 5. Now the range. The biggest y value that we saw when we went and traced, okay, the y values got closer and closer. They eventually reach 4 when x is 0, and then they come back down. But the y values never get below 0. When we had 4, y was 0, and they never got lower than that. So the range is going to be 0, positive 4. We have example 6, h of x is equal to the absolute value of x minus 5. So if we go ahead and graph that, okay, absolute value, we do alpha window, then abs, x minus 5. We're going to see that the domain is all real numbers. We can plug in any value for x we want, but the y values never go below 0. So our domain is negative infinity, infinity, and our range is 0, positive infinity. So that's just a way we can use our graphing calculator to help us with domain and range. And we have finally the difference quotient. What the difference quotient is, it's a basic definition of what is called a derivative that we use in calculus. Of a derivative used in calculus. And it's defined as f of x plus h minus f of x all divided by h when h cannot equal 0. So you may see different, we say g of x, h of x, you may see all of those different variables. So the difference quotient, what we're going to do is we're going to take our f function here. So I'm going to rewrite the difference quotient down here so we can refer to it easily. So now what we'll do is anytime I see in x, I'm going to write x plus h. That's what f of x plus h is. So f of x plus h is 3 times x plus h minus 1, which simplifies to 3x plus 3h minus 1. And f of x, we already know what f of x is. It's given to us, 3x minus 1. So then we can make those substitutions. F of x plus h is really equal to 3x plus, sorry, let's say 3h minus 1. And f of x is equal to 3x minus 1. So let's substitute those in. So 3x plus 3h minus 1 minus f of x. And remember, when we subtract polynomials, we want to use parentheses so we make sure that we distribute the negative sign to everything. Okay, so then when we distribute that negative sign to everything, we get 3x plus 3h minus 1 minus 3x plus 1 all over h. And then we combine our like terms. 3x minus 3x goes away. Negative 1 plus 1 goes away. So we are just left with 3h over h. Well, the h's will cancel. So then our difference quotient reduces down to 3. And remember, h cannot equal 0. So you may get to the point where you don't need to first identify f of x plus h and f of x, but it's a good idea to do that at first and then plug them into the difference quotient formula. So letter B is a bit more complicated because one, we have two x's and one of them is squared. So let's first start off with f of x plus h means that anytime I see an x, I'm going to replace it with x plus h. So 5 times x plus h minus x plus h squared. So we have 5x plus 5h minus, and we can use our shortcut, x squared plus 2xh plus h squared. Now remember, this will expand to that. Then we distribute that negative sign. So 5x, I did it again, this should be an h. 5x plus 5h minus x squared minus 2xh minus h squared. And again, we know that f of x is just what we were given. All right, so now we're going to plug those into our difference quotient formula up on the left, upper left. So we have x plus h, which we have 5x plus 5h minus x squared minus 2xh minus h squared minus f of x, which is 5x minus x squared all over h. Then we distribute the negative sign, and when you do these problems, yes, you're going to have a lot of different terms, but what you're going to find is that a lot of them will cancel out and make life a little bit easier. Okay, so we have 5x and negative 5x. We have negative x squared and positive x squared. So this really will simplify down to 5h minus 2xh minus h squared all over h. Well, the numerator has an h in each of these terms. So we can factor out an h, and we are left with 5 minus 2x minus h all over h. Well, now the h's will cancel, and our difference quotient, it'll be 5 minus 2x minus h. And we know that h cannot equal 0. So these difference quotient problems are really a test on, can you do your algebra? And that's why we spent a lot of time working on algebra at the beginning of the year, because they can get very complicated quickly. And if you're unsure on how to expand or to factor or to cancel things, it's going to get kind of difficult for you. So thanks for watching the video. Make sure to please like it and subscribe.